Hey Physics fam, we're continuing with the conservation of momentum and a collision problem. Here's a good one for you. A physics teacher shoots a .22 caliber rifle at 0.3 kilogram block of wood. The rifle and the wood are mounted on carts that sit on an air track, so friction is negligible. This means that any force pushing on them is going to let them flow pretty freely, all right? So that means outside forces are something that's pretty negligible. So we don't have to worry about external forces too much. Anyways, you've got a 6 kilogram gun that fires a .02 kilogram bullet with the speed of 200 meters per second. We want to know what the final velocity of the block of wood is with the bullet lodged inside. Now there's three objects we're talking about: a gun, a bullet, and the wood. But for our system that we're going to define today, we're only concerned with the block of wood and the bullet that gets lodged inside of it. So therefore, we need to set our parameters here. I'm going to call the object number 1 wood and the object number 2 bullet. As far as the gun, even though it's cool to think about that it was shot into the wood, we only are concerned with the wood and the bullet. All right, so when reading through all of this, we know that our wood block is 0.3 kilograms for its mass. So that's the mass of object number 1. For the bullet, it is 0.02 kilograms, which is a lot smaller than the wood block, which makes sense. After reading too, we know these objects initially, that velocity of that wood block is just sitting there. So its initial velocity is 0 meters per second. So that's the velocity of object number 1's initial velocity. Now the bullet is shot at a pretty high velocity here of 200 meters per second. So that's its initial velocity. So that's object number 2's initial velocity. Now the wood block ends up sticking inside, the bullet ends up sticking inside the wood block. So that means that their velocity final together is the same. And we don't know what that final velocity is after the bullet hits the wood and they go moving together. But we know it's the same because they're sticking together, right? That bullet is going to be lodged inside of that piece of wood. So if this is a sticking collision, these two objects start off individually with their own specific momentum. Then after colliding, they're going to be considered one combined system. So we'll add their mass together because their velocity will be the same at the end. So they stick at the end. So because of this in the conservation of momentum, we know that the starting total momentum in the beginning is going to be equal to the ending total momentum after the collision. So let's start plugging in and solving for it. So mass 1 is 0.3 kilograms and it's not moving, so its velocity is 0. Mass 2, or the bullet, is 0.02 kilograms and its velocity is 200 to start with. Finally, after the collision, the masses of the two objects are 0.3 kilograms plus 0.02 kilograms. And we know that together they are going to have the same final velocity. We don't know what that is yet, but we know it's going to be the same. Let's do a little housekeeping and algebra here. We know anything times 0 is 0, and 0.02 times 200 is going to end up being 4. So that means on the left side of the equation, the total momentum is going to be 4. That means after it's all said and done, after that bullet lodges into that wood block, there has to be a total momentum of 4 units. So the bullet has all the momentum right now, but once it hits the wood, obviously the wood's momentum is going to increase, so the bullet's momentum has to decrease. So we should assume that if the bullet was going 200 meters per second, the block and the bullet, the wood block and bullet, would be going less than 200 meters per second. Since the wood's momentum increases, the bullet's has to decrease. So we'll see if that's true, but let's add them up. 0.3 plus 0.02 is 0.32 times the final velocity. Let's bring that down into our equation so it's looking better. Now I'm going to solve for our final velocity. Cancel that out. and my final velocity ends up being a positive 12.5 meters per second. All right, let's think about that, if that even makes sense. The bullet was going 200 meters per second, but the bullet has very little mass. Now it hits something much more massive than it, the wood block. Does it make sense then that it went from 200 meters per second to now 12.5 meters per second? Yes, because the object has so much more mass, it's going to move at a lot slower of a pace. And again, the bullet, its momentum went down. Therefore, the wood block's momentum had to go up. That's what the conservation momentum is all about. And that's, of course, only completely true if there are no external forces and only internal forces acting on it within the system. Okay, that's a perfect world scenario. That really doesn't happen in real life, but at least we're getting a better idea and closer to what would really happen. That wood block would probably be traveling around 12.5 meters per second, even though the bullet was originally going 200 meters per second. But we know the game of masses with momentum and inertia, mass plays a huge role in that. Hopefully this helped and helped you understand a little bit more about a sticking collision at the end, since they were moving together with the same velocity. Keep up the good work, physics fam, and keep on trucking.